Good morning, grade 9. Today, inshallah, we will start with lesson 8.1 in our book, which is talking about greatest common factor. So, first of all, we have to know what the meaning of greatest common factor. The greatest common factor is the largest factor that two numbers share. Let's find the GCF of 12 and 42. First, we need to make a list of factors for each number. And we have two different methods to find the GCF. Number one, we are going to factor number 12. Then we are going to search about which numbers. Once we will multiply them together, so the answer, it will be equal 12. Like what? Like 1 and 12, 2 and 6, 3 and 4. Yani 1 times 12 equal 12, 2 times 6 equal 12, 3 times 4 equals 12. After that, we have 4 times 3. So once you are going to reserve the operation, which means you have 3 times 4, and then you find 4 times 3, which means we are going to stop. So the factors of 12, it will be 1 and 2 and 3, 1 and 2 and 3 and 4 and 6 and 12. Let's move to the next one, 42. So we have 1 times 42 equal 42, 2 times 21 equal 42, 3 times 14 equal 42, 6 times 7 equal 42. Then we will stop once we have the same number. We are going to reserve it, like 3 times 4 and then 4 times 3. Like this one, we have 6 times 7 and then 7 times 6. Then we are going to stop. So the factors of 42, it will be 1 and 2 and 3 and 6 and 7 and 14 and 21 and 42. So what are the common factors here between the two numbers? The common factors between the two numbers is 1 and 2 and 3 and 6. But what is the highest common factor or the greatest common factor? It will be equal 6. So this is how we can find the factors of two numbers. Let's move to study another example. In this question, we have 18 and we have 27. Then I want to find the factors between 18 and 27. 18 and 27, 18, 1 times 18, 2 times 9, 3 times 6. We don't have 4, we don't have 5, but we have 6 times 3. 6 times 3, exactly like 3 times 6, so we will stop. And in this case, we have already the factors equal 1, 2, 3, 6, 9, and 18. The same with 27. 1 times 27, we don't have 2 times anything, but we have 3 times 9. Go and check all the numbers. You can find 9 times 3. So you have 3 times 9 and then 9 times 3. So in this point, we have to stop. So what are the factors of 18? The factors of 18 is 1 and 2 and 3 and 6 and 9 and 18. What are the factors of 27? 1 and 3 and 9 and 27. So what are the common factors? So the common factors is 1 and 3 and 9. What is the highest or what is the greatest common factor? So the greatest common factor is 9 because it's common between them, and this is the greatest one. So this is the greatest common factor. This is another example. We have 48 and we have 60. We are going to use the same method with 48. What we have to do, so 48, it will be 1 times 48, 2 times 24, and so on. So the greatest common factor, it will be equal 12. So this is how we can find the greatest common factor between two numbers. Also in this lesson, we have to study how we can find the prime factors for any number. So if I want to find the prime factors, so there is a difference between greatest common factor and the prime factors. So if I want to find the prime factors for 48, for example, So what we have to do to find the prime factorizations. So using the prime factorizations, I'm sorry, using the prime factorizations of each number, identify the common factors between the two numbers. Then, using the prime factorization, this is another way to use with the prime factorizations, but the previous example, we were talking about how we can calculate the GCF, or the greatest common factor. In this question, we are looking for the GCF of 27 and 36 by using prime factorizations. So we can use a factor tree, or we can use the column. So how we will use the column? I want to find the prime factorizations of 27. Then we can draw a line like this for 27, and I have another line for 36. Then for 27, it will be 27 divided by 3, it will be equal 9, divided by 3, it will be equal 3, divided by 3, it will be equal 1. So this is the prime factorizations of 27. What is the prime factorizations of 36? So we have 36 divided by 2, it will be equal 18, divided by 2, it will be equal 9, divided by 3, equals 3, divided by 3, equal 1. And note that all the numbers here are prime numbers. Then, how we are going to select the numbers which it will be a common GCF. So, the numbers which you can find it's already in both two columns, we are going to use it, or we are going to nominate it. Like what? So I have 3 in the first here with 27, and I have 3. So we are going to choose 3 times. I have one more 3, and I have another 3. So we are going to nominate 3. We have 3 in this column, but we don't have another 3 in this column, so we will not use it, which means that GCF for this question, so we have 36 divided by 2, as I said, equal 18, divided by 2 equal 9, divided by 3 equal 3, divided by 3 equal 1. Then the GCF now, it will be equal 9. This is in case we use the column to make prime factorizations. We have another way, which is called factor tree. So what is the factor tree for this one? We have 27. So we can say that 27 is 3 times 9. We will stop with 3, but we have to continue with 9 because 9 is a composite figure, composite number, which is it has more, it's not a prime number, and it has more than 2 factors. Then we will continue with 9, it will be 3 times 3. So by the end, the prime factorizations for 27, it will be 3 times 3 times 3. After that, we will back to 36. It will be 2 times 18. 2, it will stop because it's a prime. And then 18, we will continue. It will be 2 times 9. Then stop 2, but continue with 3 with 9. It will be 3 times 3. So by the end, 2 times 2 times 3 times 3. So this is the answer for 27. And this is the answer for 36. Which numbers are common between both? Which numbers are common between both? So we will discover that we have 3 and 3. So the answer, or the GCF, it will be, because here I have 3 and 3, and I have 3 and 3, so the GCF, it will be equal 9. Okay, so this is how we can use GCF between two numbers, and even if we are looking to calculate the GCF between three numbers, we are going to use prime factorizations, and then, as I said, you will choose the common, or the number which is in the both two factorizations. Also, we have another part in case if I have 27 x to the power of 2 and 36 x y. We want to find the GCF in those two numbers. Then, first we have to calculate the GCF between the numbers. Already at the top, already we have 27 and we have 36. So we said that we have 9. It was 9, so we have 9. What about in case if you have a variable, okay, with exponents? I have x to the power of 2 and I have x. X to the power of 2 means x times x, right? And this one, it means x times y. What is the number which we can note that it's already in both two numbers? So I have x and I have x. So with GCF, we are going to choose x. So we can use a rule. Once we have a variable, so we will choose the variable with the least exponents. Then first, we will start to make prime factorizations for 27 and 36, and we said it was at 9. And then you have x squared, and you have x, the least common is 1, right? X to the power of 2 and x to the power of 1. So the least exponent is 1, so we will take it. I have y in the second, but I don't have y in the first, so we will not choose it. We will use only 9x. Let me give you another question. I have 6a to the power of 2, b to the power of 3 minus 2a b to the power of 2. We are looking for GCF. First, I have 6 and I have 2. We are going to check the larger number here, 6, and the smaller number is 2. 6 can be divisible by 2, so we can say that the GCF is 2 directly. What about if you want to follow the rule and you want to make factorize? Okay, you are going to make factorize for 6, which is, it will be 6 divided by 2 equal 3 divided by 3, it will be equal 1. And I have 2, it will be 2 divided by 2 equal 1. So what is the number which we can find it common in both two? It will be 2. So don't waste your time. You can check from the beginning. 6 and 2. Then 6 can be divisible by 2. So I'm going to take 2. Then a to the power of 2 and a to the power of 1. Which one is the least exponent? So I have a. B to the power of 3 and b to the power of 2. Which one is the least exponents? I have b to the power of 2. So the GCF in this question, it will be 2ab to the power of 2. Then this was our first part, or first lesson in our chapter 8 about factors and greatest common factor. Hope to all of you, best of luck, my dear students.